Hello everyone, welcome back to our channel. This is our second lecture on operating system, and today we are going to dive deep into computer system operations. If you are new to this channel, make sure to hit the subscribe button and turn on notification so you don't miss upcoming lectures. First is computer system architecture. So first let's talk about the basic structure of a computer system. A modern computer system is not just the CPU. It actually consists of one or more CPU along with several device controllers. All these components like CPU, disk controllers, USB controller, video adapter, and so on are connected through a common bus. This bus provides access to the shared memory, which means all these devices can talk to each other and exchange data. For example, when you type something on your keyboard, the keyboard controller communicates with the CPU through the bus, and the output can be displayed on your monitor using the video adapter. So everything is working together in a structured way. Next is managing shared resources. Now an important question arises, how do we manage these shared resources? This is where controllers play a key role. A device controller manages specific devices. For instance, a disk controller manages disks and USB controller manages USB disks. Interestingly, the CPU and these devices controller can actually execute at the same time, which means they might compete for memory access. To To avoid chaos, we have a memory controller. Its job is to synchronize all memory access so that everything runs smoothly and system doesn't crash. Think of it like traffic management at a busy intersection. The memory controller makes sure every device gets it done in an orderly fashion. Before moving further, let's clear up some important terms you will see again and again in operating system. First, it's bootstrap program. This is very first program that runs when you switch on or reboot your computer. It is stored in ROM and its main job is to load the operating system kernel into memory and start execution. Without it, your OS wouldn't even start. The second is interrupt. An interrupt signals that some event has occurred. Hardware can trigger an interrupt at any time by sending a signal to the CPU. For example, when you press a key, an interrupt is sent to the CPU. Last is system call, also called monitor call. This is a way for software to trigger an interrupt. It also programs to request service directly from the operating system, like file access or memory management. Now, what happens when the CPU receives an interrupt? The CPU will immediately stop whatever it was doing and transfer control to a fixed location in the memory. This location contains the address of an interrupt service routine or ISR. The ISR is like a small helper program. It handles the specific event that triggered the interrupt. Once the ISR is finished, the CPU resumes exactly where it had left off, continuing the previous task. This mechanism ensures that the CPU can quickly respond to important events without permanently stopping the current work. Next is how interrupts work. Let's break this process down step by step. The CPU stops its current task, then it transfers execution to a fixed memory location. Then it this memory location contains the address of a ISR. The ISR runs and handles the event. And last but not the least, after completion, the CPU resumes the interrupted task. This way, the system remains responsive and efficient even when multiple events are happening at the same time. Let's summarize what we have covered today. A computer system is made up of CPUs, device controller, and memory, all connected through a common bus. At a startup, the bootstrap program loads the operating system into memory. To handle events, the system relies on interrupts, whether from hardware or software, and the interrupt service routine ensure that events are processed without disturbing the CPU's main work for too long. So this is the foundation of how an operating system interacts with hardware and manage resources efficiently. That's it for today's lecture on computer system operation. If you found this video helpful, please give it a thumbs up and subscribe to the channel and share it with your friends who are also learning operating system. In the next lecture, we will continue exploring deeper concept in operating system. Thanks for watching and I'll see you in the next one. Until then, keep learning and keep coding. Thank you so much.